You saw that objects with more mass have more gravity. The Sun is the object with the largest mass in the solar system. The mass of the Sun is times greater than the mass of Earth. In fact, the Sun has more mass than all the planets added together. Because it has so much mass, the Sun has very strong gravity. The strength of gravity on Earth is about 9.8 Newton per kilogram. On the Sun, the surface gravity is 27 times stronger than Earth. That strong pull is what keeps all the planets orbiting the Sun. But that gravity gets weaker with distance from the Sun. Neptune is about 30 times farther from the Sun than Earth is. Neptune has about 17 times the mass of Earth. So even though gravity weakens with distance, the Sun still holds Neptune in orbit. This photograph of the Sun was taken from a spacecraft using a special camera. You should never look directly at the Sun or try to photograph it yourself. The Sun is the center of our solar system, and its gravity rules the motions of the planets. Next, let's look at how planets orbit the Sun. Planetary orbits are almost circular, nearly the shape of a circle. To keep something moving in a circle, a force must make it turn. On a planet, gravity from the Sun always pulls toward the Sun. That inward force keeps the orbit. Mercury, being closest to the Sun, feels the strongest pull from solar gravity. That strong pull makes Mercury orbit the fastest of all the planets. The average speed of Mercury around the Sun is about 170,000 kilometers per hour. Earth's average speed is about 100,000 kilometers per hour. Those speeds and the Sun's gravity keep planets on steady orbits, not flying off into space. Orbits are almost circular because the Sun's pull is nearly constant at a planet's distance. A planet wants to move in a straight line, but gravity pulls it inward. That makes it curve around the Sun. If gravity didn't act, the planet would go straight into space. Mercury orbits fastest because it feels the strongest pull from the Sun. Remember, Mercury 170,000 kilometers per h, much faster than Earth. Earth moves at about 100,000 kilometers per h, slower because it's farther out. Fact 1, closer to the Sun, stronger gravity, higher speed. Fact 2, farther from the Sun, weaker pull, lower speed. Fact 3, even far planets like Neptune stay bound because the Sun's gravity reaches far out. The force of gravity always acts toward the Sun. That inward force is what we call centripetal force. This inward pull balances a planet's forward motion so the path curves into an orbit. It's a continuous tug, not a single push. Quick question. Which planet orbits fastest, Mercury or Earth? Answer, Mercury, because it's closest to the Sun and feels the strongest gravity. Speeds vary, but gravity is the one controlling force. Now let's compare space with Earth's air. On Earth, moving objects face forces that slow them down, like air resistance. Air resistance happens because objects push against air particles. An airplane can increase air resistance with its wing shape or flaps to slow down faster. Pilots use that extra drag to stop safely on the runway. Space is very different. There's almost no air at all. Space is a near vacuum, very few particles, so almost no air resistance. That's why spacecraft can reach speeds impossible on Earth. For example, the Juno probe reached about 265,000 kilometers per hour during a fast Earth flyby. A spacecraft like Juno would have huge air resistance if it tried to move that fast on Earth. But in space, without air, there's nothing to slow it down, so it kept accelerating. That let Juno become one of the fastest human-made objects. Earth and the other planets move through this vacuum too, with no air resistance to slow them down. So once something is moving in space, it keeps going unless a force acts on it. The main force that can change those motions is gravity. Back on Earth, pilots deliberately use air resistance to slow down aircraft safely. Compare that to a spacecraft that cannot use air to brake. It relies on engines or planetary gravity assists. Gravity assists can change a spacecraft's speed and direction without air. Juno used gravity and precise navigation to reach Jupiter and study the planet up close. Its flybys taught us about the giant planets and the power of motion in a vacuum. If the Sun's gravity didn't act as it does, a planet would fly off in a straight line into space. Gravity keeps everything bound in stable paths instead of escaping away. Summary: mass controls gravity, gravity controls orbits, and vacuum allows high speeds. Quick, true or false? The Sun's gravity is too weak to hold Neptune in orbit. True or false? False. Even at 30 times Earth's distance, the Sun's gravity is strong enough to keep Neptune bound. From the hottest sun to the farthest planet, and from airplanes to probes, the same laws of motion and gravity explain what we see. Remember, never look directly at the Sun. Always use safe professional solar images. If you enjoyed this, subscribe, like, and share. Check your knowledge with quiz.